Okay, this is rotational equilibrium number 2. One of my favorite problems. Everybody's familiar with seesaws. So let's draw a seesaw right here. Grab the pen. Okay. It says you have a 500 Newton child sit on one end. So let's put the 500 Newton on that end. And a 300 Newton sit on the other end of the seesaw. Okay. The question is, where do you put the pivot point at to make sure they're equal? Well, if you think about it, the 500 Newton person's got to sit closer to the pivot point to keep it balanced. So let's go here and put it right there. That's called a fulcrum, by the way. Now, if this is the pivot point, we're going to be trying to find counterclockwise torques, equal clockwise torques. Now, the whole seesaw is 3 meters long, but we don't know where to put the pivot point. So let's call this x. If this is x, then the remainder must be 3 minus x. Think about it. If x was 1 meter, then you must have 2 meters on the other side. What's 3 minus 1? 2. Now, let's slide this up a little bit. The 500 newtons is pushing down this way, so the seesaw is going to want to rotate what? Counterclockwise. The formula for torque is FD, perpendicular. And if you look at your picture, since the seesaw is horizontal, then all your forces are perpendicular. The counterclockwise is 500 newtons, already a force. Woohoo! My distance is x equals what? 300 times 3 minus x. The physics is done. Now it becomes simple algebra. You have to distribute that 300, make it dance. That becomes 500x equals 300 times 3 equals 900 minus 300x. Now, anytime you have a equation, you have to do what? Letters to the left, numbers to the right. When that 300x cross the bridge, he becomes positive. That 900 stays there. 500 plus 300 is 800. You want the x by itself. You give him some 800. You give him some 800. Bam, bam. X should be okay. Let's back this bus up for a second. That's 300 times 3. Yep. That's 900 minus 300x. You have 8. Yep, 900 divided by 8. So that leaves us 9 divided by 8. If you get your handy dandy calculator out, that's 1 and 1/8, which actually turns out to be 1.125 meters. That tells you that the fulcrum should be placed at 1.125 meters, 1.125 meters from the 500 kilogram Newton person, which in turns means 3 minus 1.125 gives us 2.875 meters, and that's the distance from the 300 Newton person, which makes sense because he has to be farther away to make the seesaw stay balanced. Let's confirm that answer. I'm feeling pretty good about it. So that is correct. Woohoo. That problem right there was example number 2. Rotation. Don't forget, you can also find the solutions solved out on Edmodo.